Well, hello, everyone. Thank you for coming to Taming the Traffic, selecting the perfect Gateway API implementation for you. So we put together this panel because as of today, there are almost 30 implementations of the Gateway API, and we thought that it might be a little challenging to find the right one for you. But we aren't going to sit here and tell you that there's one Gateway API implementation that's going to work for everyone, or one that's the best. There is no de facto, default, blessed implementation of the Gateway API. But we do want to start this conversation and give you some more information and context to hopefully help you make that decision. But first up, before we get started, I wanted to see how many of you have heard of the Gateway API, if you don't mind raising your hands. Okay, a lot. And then keep your hands up if you are using it. Okay, less people. And then what about if you're using it in production? Oh, okay. All right, fair amount of people. Awesome. So the way that we structured this panel is we put together a series of questions with the help from our community, and we're going to start with those as kind of the base, and then we'll open up the mic to you. But first up, let's just do some intros. Go to the next slide. My name is Kate Osborn. I'm a software engineer. I recently joined ngrok. They have an implementation of the Gateway API called the ngrok Kubernetes Operator. But prior to that, I worked at NGINX for a few years on their Gateway API implementation.
And I'm Christine Kim. I focus on open source developer experience at Isovalent at Cisco. Isovalent itself focuses around Cilium, and yeah, I've been around Gateway API for a little bit. Yeah.
I'm Mike Morris. I work at Microsoft as a product manager on our upstream open source networking team. I primarily work on Gateway API and Istio.
I'm Spencer Hance. I'm a software engineer at Google. I work on GK Gateway. I've been working on GK Gateway for a couple years now, and then before that was working on GK Ingress.
I'm Arko. I'm a maintainer on the Envoy Gateway project. This is a sub-project inside Envoy that implements the Gateway API to manage north-south traffic. Also a reviewer and a contributor to the Gateway API. And I'm an engineer at Tetrate, where I work on TEG, which is an enterprise offering of Envoy Gateway. So let's start by addressing the elephant in the room. I'm a user who likes Ingress. Why should I change to the Gateway API? Spencer, do you want to take that one?
Okay, do you want to go first? Or? Sure.
Okay, so something I hear a lot about the Ingress API when compared to Gateway is that it's simple. And I definitely agree with that. It is a simple API. It's easy to use. But when you need more advanced routing capabilities like traffic splitting or request mirroring, header manipulation, those types of things, that's when Ingress starts to fall short. And you reach for like annotations, right? And annotations are also simple. They're string-to-string values, but they're unstructured, which means you can't apply schema to them, so they aren't validated that way. You rely on the implementation to validate them at runtime. And sometimes if that's not done well or in a robust way, that can open you up to some security vulnerabilities. In addition, I think they're slightly more challenging to use because they're not as expressive. You're limited to strings. And finally, they're not standard. So if you're using an NGINX-based implementation and you want to switch to, like, say, an Envoy-based implementation, those annotations aren't going to be the same, and you're going to be spending a lot of time mapping between the two of them. So what the Gateway API lacks in simplicity, it makes up for in expressiveness. So all of those advanced routing features are built in. They're first-class APIs on the Gateway API resources. So they are structured, they are validated with the schema, and they're standard across all implementations. So if you switch from an NGINX-based to an Envoy-based implementation of Gateway API, you'll just be able to use the same resources in the same way. So I think if you are only performing simple routing, then maybe you stick with Ingress for now. But if you're doing more complicated routing or you have a bunch of implementation-specific annotations, it's probably a good time to start looking into Gateway API. Spencer?
Yeah, I can also comment on this. So I think there's a couple things that I would want to cover. You already covered, Kate, that there's much more of the surface area of the API is inside the core API, and it doesn't need to be added as an extension like Ingress. And I think that's one of the things that, and maybe I don't need to actually sell everyone on Gateway because of all the hands that we saw at the beginning. There's a lot of people using it, which is great. But yeah, there's just like generally because more of the feature set is actually inside the core API. You can describe it via Gateway directly without a vendor-specific extension. There's less vendor lock-in. So sometimes we have customers who say, I don't want to necessarily use GK Gateway because I don't want to be locked into this, specific using only GCP, let's say. But that's the sort of the beauty of the Gateway API itself, is that most things can be expressed, without an extension. And so you can easily move between implementations if you want to. And maybe one of the takeaways from this talk is that if you still can't decide on which one is the best one for you, is that you can move between them. And that's kind of that's one of the main points of it. Also, another thing is the role-oriented architecture of Gateway versus Ingress. You have like the infrastructure provider owns the Gateway class. You have the cluster operator might own the Gateway, and then you have the application owner or application developer who owns the HTTP route and the services. And that just, if you configure that with your RBAC setup, it's just kind of a nice, easy way to handle the separation of resources and keep it secure. And I think lastly is just that, as most people know, there's much more development and involvement now with Gateway versus Ingress. And so, if you are looking for something new and you want to use it for a long time and you want to see something that's going to be very well maintained and continue to grow and develop, then Gateway is obviously the choice for you.
All right, so with nearly 30 implementations, how should users approach the decision-making process? What are the top 3 factors they should consider when choosing an implementation?
So coming up with 3 factors is hard. Let me break it up into 3 steps, and hopefully try to eliminate from 30 to 7, or 5 to 7, then from 7 to 3, and then 3 to 1. Step 1 would be feature parity, aka spreadsheet time. This is where you jot down all your use cases and map it to implementation capabilities. One good resource for this is the conformance report page in Gateway API built by Christine and Matteo. Another good resource is the Ingress table in the learn.k8s.io page. Another thing you want to measure in this step is cost, specifically migration cost and purchase costs. So hopefully by the end of this step, you've narrowed it down to 5 or 7. In step 2, we'll hopefully try to narrow it down to 3, using data plane and its differentiators. For example, Envoy proxy has some rich observability and extensibility, and NGINX does really well for serving static assets. Step 3 is POC time. Hopefully, we have 3 implementations that we've narrowed it down to. And this is where we actually test out these implementations and see if the features actually work. I recommend sort of logging your experience down so that you can measure operational cost. Another thing to do in this step is running perf tests that are specific for your kind of traffic and scale. Yes, I think we can sort of break it up into 3 steps of feature parity, data plane differentiators, and POC to narrow it down from 30 to 1.
So I'll throw another wrench in there. One of the other perks of using Gateway API is that it's not just limited to north-south traffic management. You can also use Gateway API for east-west traffic, so your service mesh traffic. We have multiple meshes that have support for Gateway API. So when you're looking at this, it's not just limited to your mesh necessarily, but that may also inform your decision of which north-south gateway you're using to pair with that mesh. So if you're using Istio, Istio has a built-in Ingress gateway with support for Gateway API, which is going to be seamless to have connectivity between the gateway and the services in your mesh with MTLS. If you're using Linkerd, they don't have their own Ingress, but they do have a great way of integrating with other gateways. So you also might want potentially some of the experimental features that Envoy Gateway is adopting earlier than some projects. So pairing that with one of your meshes or using a cloud provider specific Gateway API implementation at that north-south layer, potentially for better integration with some like DNS stuff, certificate management, generally better integration with the rest of your presence on that cloud.
Thanks, Mike.
All right. So how do day 2 operations differ across implementations? Are there specific debugging or observability features that are critical? And Spencer.
Yeah, I can answer this one. So I think we should quickly just define day 2 operations. So in this sort of paradigm, you have like day 0 operations, which might be sort of the pre-work before you actually deploy something. You have day 1 operations, which is the work you're doing to actually deploy your integration, and then day 2 is sort of the ongoing maintenance load that you have to keep it going. So I think like things to look for with day 2 for gateway implementation specifically is probably one of the big ones is, and you might see this partially as part of day 1, so it's a little bit cheating, but is the CRD management. This is sort of one of the interesting things about Gateway API is that it's developed outside of the core Kubernetes tree. And so because of that, the installation of the CRDs is either a step that you do before you actually deploy your implementation in the cluster, whichever one you choose, or if your cloud provider does it for you, then that is potentially an added benefit of something that you don't have to manage going forward is like version upgrades, version management, et cetera, because especially as you are potentially deploying multiple implementations, which is, I guess, another takeaway from this talk or from this panel is that you can use multiple depending on if you're doing, you want to do north-south and also east-west. The CRD management can get kind of messy and, doing version upgrades and et cetera. And so if your cloud provider can handle that for you, with their implementation, that could be, a benefit that you might want to look for. I think, other than that, other things to look out for is observability, and is obviously crucial. I think a lot of the implementations for Gateway use Envoy as the underlying proxy implementation. Envoy provides a lot of metrics that I think are super useful, but also I think especially when you're dealing with a cloud provider specific or an out of cluster implementation of a proxy, I think it's really important to make sure that it has all of the metrics and observability you need, because it is something that you don't manage yourself. It's a managed resource, a managed load balancer, application load balancer that lives outside your cluster.
Yeah, just also echoing Spencer, metrics are super important. That's how you show up in management, like what is going to be good and like justify those cost overhead. So for example, like Cilium has a great feature that's called Hubble, and that's really good at, just peeking into your cluster and your north-south traffic and making sure that your metrics are aligned and, everything is flowing, your traffic is going good. Yeah.
All right, so is there an effort to standardize implementation behavior, or is kind of diversity the goal? And how do folks here try to balance flexibility and sharing some of the benefits of their implementations with conformance and fitting into what the agreed upon standards are?
So I'd say the primary goal is to have conformant behavior for the set of common features that are common across most implementations. But as a secondary goal, flexibility is needed. So implementations have the freedom to build on top to solve user-specific problems.
Yeah, I agree with Arko. The goal is definitely to standardize like as much as possible wherever possible, but like you can't always. So like one easy example is if you have proprietary configuration. So like for NGINX example, there's NGINX config that just doesn't apply to Envoy, right? So it's going to be really hard to standardize that in the Gateway API, but users still want to be able to tweak those configuration settings. So in that case, you can build on the Gateway API, like Arko said, using some of the extension mechanisms. And one of those that we used at NGINX were like policies. So you could create policies that allow users to like set client connection settings or upstream settings for NGINX, but they still like attach to Gateway API resources. And that extension mechanism is still standard, like itself, even though the behavior and the implementation might change. Like you know what policy attachment is and looks like and how to use it generally. So there's still some standardization there. And then I also think like there are cases where an implementation might want to deliver a feature faster than is possible when you're trying to standardize it. Like those standards don't, like they're not easy to develop. They don't come overnight, and they just take time. So like auth is a really good example of that. The Gateway API has been working on auth for a while, and they're getting closer to a standard for it. But obviously, like implementations have a business need to deliver authentication to the users, so they like might use some of those extension mechanisms again, like policies or filters, to be able to let users configure auth before the Gateway API can, come up with a standard. So I think it's just a balancing act, and just always trying to figure out if there's common ground among the implementations and to talk to one another and figure out if we can create standards where there aren't any today and just make it a better user experience.
So collaboration is a key part of OSS. How do implementers work together despite having competing solutions? Who wants to take that one?
So I think all implementers benefit from good user experience. Gateway API has evolved from Ingress, providing a more richer and expressive API. Yes, there's room for improvement, but it's still a step up. 3 years ago, when we started Envoy Gateway, we made a bet to purely support Gateway API. That's something Nick championed, actually, and it's paid off. Adoption of the API has been pretty positive. So I think there is value for all of us to work together to provide a common user experience, yet compete on, value adds on top.
So I'm going to tell a short story here, and hopefully this is going to inspire some folks in the audience to help contribute to the Gateway API and build this project together. So I attend regular Istio weekly meetings that are open to contributors, to users, et cetera. And in one of those meetings a few months ago, a user at Box.com, Eric Bishop, he came to an Istio meeting and said, I am looking for a specific feature that's available in Envoy that's not yet available in Istio. It's budgeted retries. So I was aware that this is also kind of how Linkerd has typically done retries using a similar strategy historically. And I encouraged him to, instead of trying to just do this in Istio, because at Istio at the time we're focused on ambient and we're looking to use Gateway API as much as possible for our future configuration, I encouraged him to bring it to the Gateway API meeting and to try to make it into a feature proposal for something that we could potentially adopt across multiple implementations. So I was happy to kind of like shepherd and support him in doing that, and it was voted up for inclusion in the recent scope for 1.3, the upcoming version of the Gateway API. And yeah, we worked through a GEP together, we worked through an implementation, and we got feedback and review from Linkerd. We had folks at Google who I wasn't aware would be interested in this, but chimed in on the pull request implementing this. And we identified a kind of like gap in differentiation between Linkerd's existing implementation and Envoy's. And we identified basically like there's a small change that we could do to Envoy to be able to have a common spec supportable between both implementations. And yeah, we're anticipating doing that work soon, and we're really excited to get this spec into experimental. And hopefully that's something that'll resonate with some of the folks in this room. And similarly, you'll be able to bring your use cases to these upstream spec meetings. Like, we're welcoming. We'd love to work with end users.
So the Gateway API keeps evolving. What upcoming features or improvements are most exciting for implementers?
So I think one of the more exciting things is the announcement of NGate. Well, you guys have probably already heard, but there's going to be a talk today at 5:45 by Rob and James, and they're talking about NGate. And what's really exciting is that we're really focusing on user experience and usability, making the process seamless to go from Ingress to Gateway API. So that means we need to talk to end users and hear what you guys care about and what we need to do as upstream to make it more seamless for you. Anyone else wants to add on to that?
I asked this question, but I can also answer it, I guess. But so I think one thing I'll plug real quick is that the folks at Google and GKE have been working very closely with the community on the inference extension for Gateway. And so for anyone who is working or using inference serving workloads on Kubernetes, I think definitely check out that extension. There's quite a few companies involved. There is a keynote about it on Friday with folks from Google and also ByteDance. And so I would definitely check that out. But yeah, we're looking forward to supporting that in GKE.
I mean, Kate already mentioned this, but auth. So tackling authorization and authentication, and hopefully getting some of those really common use cases like JWTs and OIDC into the actual Gateway API spec.
Yeah, sure. All right, we're going to do a quick lightning round because we want to also open up the mic to you guys, but we'll answer these 5 questions in rapid succession. So, Spencer, you want to take it away?
Biggest pain point would be, I'm going to say CRD management as an implementer.
I think biggest pain point right now is not having the CRDs installed when you have it and run in your cluster.
I don't have anything to complain about right now, so I'm just going to skip.
I'll say policy visibility. Policy attachment's great, but understanding what resources are affected by a policy can be challenging still.
Yeah, I second that. Implementing policy attachment is complex. Okay, we'll go the other way. So favorite Gateway API feature, I think right now, filter, I think is my favorite.
I'll say a kind of weird one, reference grant. It's, I see Rob laughing in the audience. So it's something that is an explicit contract to make sure that we're offering security between connections in different namespaces and really helping to delegate that control safely. And Rob's also been doing some work to try to get that concept into upstream core Kubernetes. So other implementations have uses for it too.
So I'll mention the controversial one, which is policy attachment. But it really allows all of these implementations to kind of build implementation-specific features targeting their specific users.
I like it's not really a feature, but like the idea of personas. I think that's a really good story to have that, the application versus the cluster operator, because we see that teams are really large and not one person manages everything.
So I'm also going to say policy attachment. For anyone who's used GK Ingress before and is familiar with our own custom CRDs for front-end config, back-end config, et cetera, they were kind of a pain, and I think policy attachment made things a lot easier for us. And then, so I'll go next. For best debugging tip, I will say status, gateway status.
Status.
Resource status is your best friend.
Status.
Yeah, status, kubectl describe. Oh, and gateway cuddle. Use the gateway cuddle tool. That's also really helpful. What's next for your implementation in 2025? ngrok is currently working on just adding API surface for the gateway API, so adding support for some of the experimental route types like TLS route and TCP route.
Istio, we can go next. Continuing on that one though, Istio's current focus is ambient mode, so we're currently working on multi-cluster for ambient right now. And one of the other highlights of ambient is that we're all in on Gateway API as our primary configuration interface for traffic routing. So definitely expect to see us continue to drive work upstream in the Gateway API project, to extend the functionality and kind of double down on using that as much as possible.
I'm going to say zone-aware routing from the gateway to the backends.
Salim's going to continue doing some hardening, so TCP and UDP routes specifically.
And then I know I already mentioned this, but the inference extension for Gateway API. All right. Okay, so we have time for open mic questions. There is a microphone straight ahead of me. If you would like to ask a question, just please say it into the mic.
Yeah, well, if no one has any questions, I think we'll all stick around as well after. So if you want to pick our brains or you're too intimidated. Oh, yes.
Is the idea with TCP and UDP route to replace service type load balancer, or is that like they'll live together for a while, or but strategically it's the long-term vision, or what?
I think for now they're just going to live together. We still have to do some engineering planning work for like this year in 2025, but for the most part, it's not here to replace.
I know there's a few folks who have some like long-term ambitious ideas about deconstructing service, but that's not something that's in the immediate time frame to worry about yet.
So in what scenario should someone use TCP route versus service type load balancer?
So I think the gateway generates the load balancer for you if you're using an in-cluster implementation. TCP route would let you latch on to that same listener and route TCP to your backends. Say if you have a Postgres backend, you could use TCP instead of using another protocol like HTTP route or gRPC route. Yeah.
And you could also take advantage of some of the functionality of Gateway API, like traffic splitting and things like that, for like Canary or AB deployments.
Thanks.
I guess since there's no question so far, at least, I can use this time to plug. There is a talk by, I forget who, from Docker tomorrow. If you want to hear about, someone who's, their story of actually using Gateway API as a customer. And so I think that's pretty valuable for folks to go to.
And I also want to mention a project called Ingress to Gateway if anyone's looking to migrate from Ingress to the Gateway API. This tool will help translate those Ingress resources into Gateway API resources. So please give that a try. And is that it? Yep. All right, well, that's it. Thank you guys so much. Please leave a review from the QR code.